All right, let's talk through the solution for example 3.4. So we want to know what's the pressure 30 meters below the surface of a lake. And we're given that the density of water is equal to 1,000 kilograms per meter cubed, and that the atmospheric pressure is 101,325 pascals. A pascal is a newton per meter squared. A newton is a kilogram meter squared per second squared. And then we can see that, a pascal is basically in SI units. So that's important because we want pressure in the right units. Then we also know that G is 9.81 meters per second squared. So we know that the absolute pressure anywhere underneath the surface of a fluid is going to be atmospheric pressure plus gauge pressure. And we saw in the lecture that pressure is equal kind of to this P naught plus rho GH. So it's kind of a different expression of the same formula, right? Gauge pressure basically is equal to the rho GH in this scenario. So the idea is if we're looking at the pressure, we've got to first figure out what's going into this gauge pressure, and then this is just the atmospheric pressure. So what that's going to mean for us in this example is that the absolute pressure is equal to the 101,325 pascals plus we have 1,000 kilograms per meter cubed for our density. We have 9.81 meters per second squared for our G. And then what's our H? Well, our H is the distance underneath the fluid. And so that's actually the depth of the lake. So that right there is going to be the 30 meters. So if we pull out our calculator, let me grab mine really quickly so that we can do this calculation together. If we take the 1,000, multiply it by 9.81, and then multiply that by 30, we get 294,300 pascals. And we're going to add that to the 325 that we already had, or 101,325 we already had. So let's do that so we can get a number. And what we'll find here is that the absolute pressure is going to be 395,625 pascals. So this is just a simple example to give you an idea of how to get gauge and atmospheric pressure working together.